Hi, in this video we are going to go over the solution of the problem valid anagram. So problem 242, and we are given two strings s and t, and if it is anagram we are going to return true, and if it is not we are going to return false. But what is anagram? So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So we are not going to change the numbers, so that should be exactly same numbers. So for example, here if I have 3 A's in this word, so I should have 3 A's here, 1G, 1G, and so on. So for example 1, it is possible to rearrange S to get T, but for example 2, it is not possible to do that because I have here R, I have here C, so this is not possible. Okay, let's start solving the problem. I have a string S and a string T, and I have a function. I need two inputs, S and T, and I'm going to solve this problem using dictionaries. So I'm going to do this. I'm going to call the one dictionary D1 first as an empty dictionary, and I'm going to go for a for loop and say for character 1 in S. I go all of the letters in S. If that is not in the dictionary, if character 1 not in D1, I add it. I say D1 character 1 equals 1. But if it is already a part of that dictionary, I said D1 character 1 plus equals 1. Let me just run this and return D1, that you see what is happening. If I run that, I get this one. This is the dictionary D. You see A is 3, I have N, G, and R. That is dictionary D1. Let's make a dictionary also for T. I call it D2. Call it D and say for character 2 in T, if character 2 not in D2, D2 character 2 equals 1, else D2 character 2 plus equals 1. Now I have two dictionaries, D1 and D2. You see here I have D1 and this is D2. Now it's very simple. I can just compare them and say, okay, if D equals D2, I return true, and if it is not, I return false. So I don't need this return anymore. So let's run it. This is true because, for example, you see here I have A3, I have A3. I have N1, I have N1. So these two dictionaries are identical. You might see, okay, A appears at the beginning and A here is at the second, but in dictionary order is not important. So, and that is basically the solution of this problem. Let's look at the time and the space complexity. So for the time complexity, let's see what we did. So we have one for loop here. So that is or big O of n here. I have another for loop here, that is big O of n. And then I have a comparison of two dictionaries that we can easily be done that with order of n, because we can go for one dictionary and just compare the keys. So that should also be order of n. So therefore at the end our time complexity is order of n. Okay, now let's talk about the space complexity. I created two dictionaries, D1 and D2, and you saw that here that those dictionaries could have different uh, more than one space. But what could be the maximum length of this dictionary? Is it going to be n? No, it's gonna be limited to the number of characters. So for example, in alphabet we have 32 for small and 32 for capitals, and then we have if we want to include numbers, we can have numbers here. So but it maximum it's gonna be 32, 64, 100, but that is always a constant number. It's not gonna go to infinity. Because of that, the space complexity is order of 1. Again, this dictionary length, the length of that doesn't go to infinity if n goes to infinity. If I have a very, very large string here, if that I have that, these numbers are going to increase. A is going to go to 200, 300, but the length of the dictionary is not going to go infinity. As a result, the space complexity is order of 1. Okay, this is the solution to the problem 242 valid anagram, and thank you again for watching this video.